So let's look at a couple examples here. So we have specific heat, and there's your equation here at the top. This T really means delta T. That just means a change in temperature. Okay. So if we come down here, I like to underline my data. So I have 12 grams. Grams is mass. And if the temperature changes from 13 to 45. So 13 was TI, and this is TF. So you can also think of this as being TF minus TI, which is final minus initial. And the question is, what is the heat? So heat is Q. So if we look at this equation, we're looking for Q. C we're going to find on page 1 of your reference guide. M is 12. And your change in T is going to be your final, which is 45, minus your initial, which is 13. So Q equals 12. And we're talking about water. Yeah, talking about water, which is right here. And water has 3 different specific heats. It's on page 1 of your reference guide in the middle. I think it's the bottom row in the middle chart. And so it's for steam, liquid, or solid. So if it's 13 to 45 degrees Celsius, that's a liquid. So we're going to use the 4.18 because it is a liquid. And then 45 minus 13. So you end up with 1605.12 joules. There's that one. All right, if we look at the second one, this one's a little harder for math because it's looking for your final temperature. So it's looking for TF. We're talking about copper. So we're not going to use the 4.18 for specific heat because we're not talking about water. We're talking about copper. That's going to be on page 1 of your reference guide at the bottom. 3 grams. Grams is mass at 47 degrees. So we're starting TI is 47 degrees, and I missed 35 joules. Joules tells you heat, so that's Q. So now you just fill in 35 equals your specific heat for copper is 0.385. Again, that's on page 1 of your reference guide. And then mass is 3. And then TF is what we're looking for, minus TI, which is 47. Now for this, you've got to multiply the 0.385 times 3 and do 35 divided by that to give you TF minus 47. And then you can add the 47. So you would have 35, you can see that, divided by 3 times 0.385 is going to equal TF minus 47. Okay, so then to get 47 by itself, or I'm sorry, to get TF by itself, you have to add 47 to both sides. So that's a calculator. You might have to play around in your calculator to get that one right. But 34.99 degrees Celsius. What's cool about these problems is you can check yourself. So if you put 34.99 into TF and you work this out, so you would put 34.99 minus 47 in your calculator, enter, and then times by 3 and times by 0.385, you'll actually get 35. So that's a way you can check yourself, which helps. All right, last one, law of conservation of energy. If we put 2 things together, their temperature is going to average together based on their specific heats and how much you have. So for this problem, you have lost and gained. Technically, I guess your negative should be here. If you've lost, that one should be negative. Get rid of that. it doesn't really matter as long as you remember to put a negative on one side. So what I do for this one is I underline either lost or gained, and I circle the data that goes with the other one. So if I'm talking about iron, I'm going to define iron as the one I'm going to underline, which works because we're starting at 100 and we're going to decrease. Mass of iron here is in grams, 100 degrees Celsius. It's not telling you that it's got a final temperature, but we're going to keep reading so we can figure out what this is going to be. And it's dropped into an insulated container of water. So water is what we're going to circle. The mass of the water is 132 grams, and its temperature before adding the iron is 20 degrees. So it says before adding the iron, which tells you that this, I'm so sorry, I did not realize you couldn't see it. This is your initial temperature. And the question is final temperature, TF. That's your question mark. So that makes this TI. So set up one side of the equation first. So let's set up the iron side. So this is going to be iron. This is going to be water. And it's going to really help you if you do this to keep these things separate. Specific heat, or we got mass, sorry, 21.5 grams. And then the specific heat of iron is 0.449. That's on page 1 of your reference guide at the very bottom. And then we're looking for TF, and our initial temperature is 100. Okay, on the other side, we have 132 grams. So this is circled, this is underlined. Okay, so 132 grams here. At 20 degrees Celsius, water is a liquid. So we're using the 4.18 again. And then we're looking for TF, and we're going to minus 100. I'm going to turn it on the back of this page because I'm going to actually walk you through the math on this one. I think that will help you. I got stuff on the back. Sure, let's just do it on this one. Actually, you know what? I'm just going to walk you through my problems that I did. Okay, so here's the problem that I just set up on the other sheet of paper. And then you have your negative. So iron is actually losing heat because it started at 100 and it was put in water that was 20. So iron is going to cool off. The water is going to heat up. So if it's cooling off, that's the negative one technically. So remember to change that or add that negative. Multiply your 21 times your 0.449, and that's where your negative 9.6535 comes from. Over here on the right side, when we talk about water, 32 times 4.184. That's where your 551.76 comes from. And then we have to distribute this 9.6 into your parentheses. So it's negative, because don't forget about your negative, times your TF, and then negative times negative gives you a positive. So that's why that's positive. And then on the other side, I have 551.76 TF, and then minus, because there is no extra negative. There's only one negative. So times these two, and you get 11,035.2. Then you need to combine like terms. I like to get rid of my negatives at this point. So I would bring the 9.6535 to the right side, and then negative 11,035.2 to the left side. I just do that because I would prefer to not work with negatives. It's just one less thing to look at. Once you get to this point, if you say 12,055 divided by 561.4135, and you want to keep all these decimals, this is a lot of math to do. You can't lose your decimals up here, so that's why I wrote them all. You divide them and you get TF is 21.38 degrees Celsius. Now, when I first did this, I was like, ooh, that didn't change a whole lot from this 20, and that changed a lot from 100. But if you look, you have 132 grams of water that you're heating up, and you only have 21.5 grams of iron. So you have a lot more water to heat up than you have iron to add the heat. Also, if you look at your specific heat of water is 4.18, and it's roughly 10 times that of iron. So it does make sense for it to be a lower number here. That makes sense. If you plug this TF into both equations, and you solve it, you'll get the same answer. And so it's correct. You can check yourself. Have a good day.